The output of a telephone transmitter takes the form of a current that varies with time. A telephone receiver is used to convert this current back into a true likeness of the speaker's voice. If this modulated current is sampled at suitable intervals, and the resultant signals transmitted to the distant end of a circuit, it is still possible to reproduce an acceptable likeness of a speaker's voice. This process of sampling is known as pulse amplitude modulation. The amplitude modulated pulses can be represented by sets of binary digits according to a prearranged code. This form of presentation is referred to as pulse code modulation. The intervals between the sets of binary digits can be usefully utilized in conveying additional channels. This is a technique known as time division multiplexing. Tandem exchanges are a feature of the telephone network in the larger cities of this country and enable the many local exchanges to be efficiently interconnected. The routes between the various exchanges are known as junction routes and invariably carry a high level of traffic. A convenient way of providing for circuit expansion on these junction routes is by means of PCM techniques. Two pairs of wires equipped with PCM apparatus will provide 24 circuits where originally only 2 existed. With conventional tandem exchange design, it is necessary to convert the signals back into their original form in order that switching can take place. If, however, the tandem exchanges were capable of switching PCM signals, then the transmission terminals could be eliminated and the cost of the scheme considerably reduced. These thoughts have led the research department to embark on a project with the object of proving the viability of an exchange capable of switching time division multiplexed PCM signals. Meetings under the leadership of a senior engineer enabled the various aspects of a telephone exchange to be discussed. At the same time, traffic studies were undertaken to determine the best switching configuration for the exchange. Meanwhile, a search was initiated in order to find a site suitable for a field trial of a tandem exchange. Empress Telephone Exchange in the London telecommunications region emerged as a likely building, and henceforth the project became known as the Empress Experiment. Digital PCM signals are similar to those used in computers, so it was possible to exploit some of the components and techniques used by these machines. Here, for instance, the many elements used in the construction of logic gates are now available in integrated circuit form. Laboratory tests were conducted in order to assess the performance of these new devices. Information storage is an essential part of any telephone exchange, and these ferrite cores, each only 2 mm in diameter, appear to offer an inexpensive form of storage. Approximately 1,000 such cores have been built into this unit, which is about to be tested for reliability. Alternative forms of storage, such as the glass delay line, were also investigated. A radio frequency noise generator was used to investigate the effects of electrical noise on the system. Electrical interference was kept within acceptable limits by a careful choice of paths for the numerous signal leads. The exchange was by now beginning to take shape. Logic diagrams were prepared for each of the units, the overall picture becoming clearer as the various diagrams were combined. Sketch layouts were prepared from the logic diagrams, and finally accurate master layouts produced. These masters, when photographically reduced, gave negatives of accurate dimensions from which the required printed circuit boards could be prepared. The numerous connections to the integrated circuits were welded into position on the printed circuit boards. At this stage, the printed circuit boards were fitted in frameworks and the remainder of the components and wiring installed. The completed units received many tests before being passed as ready for service in the tandem exchange. The racks were now nearing completion, and soon the many units would be installed in their final positions in readiness for the commissioning phase of the experiment. As the sections of the exchange were commissioned, they were brought under the control of automatic routiners. These routiners were able to identify faulty conditions within the exchange and record the details on a teleprinter. During the final stages of commissioning, staff from Empress Telephone Exchange received instructions in the maintenance of the apparatus that would soon be under their charge. Almost 3 years after its inception, Empress Tandem Exchange was complete and ready for its final trials under live traffic conditions.